Hello friends, welcome to this channel by the name of Royal Mentor. Today in this video we are going to study about reaction of period 3 elements with water, oxygen and chlorine. In the previous videos we had already studied the physical and atomic properties of period 3 elements. Today in this video we will discuss about the chemical properties of period 3 elements. So the chemical properties of period 3 elements are of three types: reaction with water, reaction with oxygen and reaction with chlorine. Out of these three chemical properties we will study about the reaction of period 3 elements with water. So in period 3 elements, the first element is sodium. You guys better know that sodium metallic character is very high, due to which sodium is highly reactive. Whenever we put this sodium in water, as a result the reaction begins rapidly. So here I have already written that this reaction is a rapid reaction. Okay, so now what will be the final product when sodium react with water? The final product will be the hydrogen gas, which is produced in the water in the form of bubbles, and these bubbles of hydrogen gas will split or rupture on the surface of water. Along with hydrogen gas, a colorless solution of sodium hydroxide is also formed in the water, and this colorless solution is highly basic, and this colorless solution sodium hydroxide will dissolve in the water. Okay, and hydrogen gas will be lost from the water in the form of bubbles. Now this reaction is an exothermic reaction, because the total energy of product, mean sodium hydroxide, is less than the total energy of the reactant, sodium and water. As a result the energy is released. Okay, this is how this reaction is an exothermic reaction. So here you guys can see that sodium undergoes exothermic reaction with cool water producing hydrogen and colorless solution of sodium hydroxide. However, one thing you guys might notice during this reaction, at reactant side the sodium oxidation state is 0. Here you guys can see sodium oxidation state is 0, and in the product the oxidation state of sodium is +1. Okay, it means sodium lost 1 electron and become oxidized. As I told you before that sodium metallic character is very high, due to which it lost electron in the reaction. So now we will study reaction of magnesium with water. Whenever we put down this magnesium metal in water, a very slow irreversible reaction is established between magnesium and water H2O. Okay, so you can see that this reaction is slow and becomes slower with the passage of time. Okay, a very clean coil of magnesium dropped in cool water. So we drop magnesium coil in water. So now what will be formed in the final product? A colorless solution of magnesium hydroxide will be formed in the final product along with hydrogen gas in the form of bubbles. Okay, thus these bubbles float to the surface of water and rupture on the surface of water, and magnesium hydroxide dissolve in water. Magnesium hydroxide is also called magnesia. So one thing you guys should keep in your mind, that the formation of hydrogen gas is very slow, and this slow production of hydrogen bubble is the proof that this reaction is very slow. Okay, comparatively to sodium, magnesium reaction is very slow with water. Now the question arises that why this reaction is very slow. The reaction is slow because magnesium hydroxide solubility is less than that of sodium hydroxide. Okay, this is why magnesium hydroxide is also called weak base. Magnesium metallic character is low than that of sodium, due to which magnesium ionization energy is greater than that of sodium. As I told you that magnesium character is lower than that of sodium, it means that magnesium lost electron very weakly. Sodium lost electron quickly, and magnesium lost electron from their valence shell very slow. So this is why magnesium metallic character is low, and magnesium ionization energy is greater. It means that the maximum a lot of energy is required to lose 2 electron from the magnesium valence shell. Okay, so this is why magnesium ionization energy is greater. Okay, so now whenever the magnesium piece is put down in water, okay, then a saturated solution of magnesium hydroxide is formed. So now the production of more magnesium hydroxide will not dissolve in water. Okay, and magnesium hydroxide which is not dissolved in water now it will deposit on the surface of magnesium metal. Okay, so the metal surface will be covered due to deposition of magnesium hydroxide on the surface of metal, and the reaction will become slow down. Okay, so you guys can see here the third point, eventually magnesium metal get covered with small bubbles of hydrogen. Okay, and magnesium hydroxide is formed as very thin layer on the surface of magnesium metal, which tend to stop further reaction. So one thing you guys should keep in your mind, that here in reactants magnesium oxidation state is 0, and in product magnesium hydroxide, in magnesium hydroxide the magnesium oxidation state is +2. It means a lot of energy is required to lose 2 electrons from magnesium. In magnesium hydroxide, magnesium +2 means that magnesium is oxidized twice. Okay, in first ionization magnesium lost 1 electron, and in second ionization magnesium again lost 2nd electron. So this is why magnesium reaction is very slow as compared to sodium. Now we will study reaction of magnesium with steam. However, if we react magnesium metal with steam, which is high energetic, then magnesium react very rapidly with steam. So here you guys can see that the first point is this, that this reaction is rapid. Okay, in case of reaction with steam, the magnesium hydroxide will not be formed, but magnesium oxide is formed along with hydrogen gas, which is white solid. Magnesium hydroxide is white solid. So magnesium oxide is white solid. Magnesium oxide is also called magnesia. So you guys can see here that magnesium oxide is also called magnesia. Magnesium burns in steam. The third point is this, that magnesium burns in steam with its typical white flame to produce white magnesium oxide, as I told you this before, and hydrogen. So if we react magnesium with water, H2O, so H2O in gas form with steam, so what will be the product? Magnesium oxide, which is white magnesium. Okay, and along with hydrogen gas, these two things will be formed due to the reaction of magnesium and water. Now we will study reaction of aluminium with water. Okay, if we put this aluminium metal in water, nothing will be happened, only this aluminium metal will be settled down in the water and reaction will not be proceed. Aluminium react only with steam and when they are in powdered form. Okay, so when aluminium react with steam, so what will be the result product? As a result, white aluminium oxide will be formed, which is also called alumina, and hydrogen gas will be formed along with aluminium oxide. Okay, here you guys can see that the first point is this, that aluminium powder when heated in steam produce aluminium dioxide and hydrogen gas. So now this reaction is slow than that of magnesium, because you guys can see in reactant aluminium metal oxidation state is 0, and in product the oxidation state of aluminium dioxide is +3. In aluminium dioxide, the aluminium oxidation state is +3. It means 3 electrons are lost by aluminium metal. Okay, for this losing of electron from the valence shell, too much energy is required. Okay, it means that aluminium ionized 3 times. On first ionization, aluminium lost 1 electron. Then on second ionization, aluminium lost 2nd electron, and then on third ionization, aluminium lost the 3rd electron. Okay, so on this way 3 electrons are lost by aluminium metal. For this losing of electron from the valence shell, too much energy is required comparatively to magnesium and sodium. Aluminium ionization energy is greater. Okay, now these are the reasons due to which aluminium reaction is slower than that of magnesium. So you guys can see here on the screen that this reaction is relatively slow because of the existing strong aluminium oxide layer on the metal. Okay, this is the next reason of the slower of aluminium reaction. Okay, so as I told you that we use powder form of aluminium metal. Why? Because aluminium are hard. When aluminium dioxide are formed, so these aluminium dioxide deposit as a white hard layer on aluminium metal. Okay, and stop further reaction. but when we use the powdered form of aluminum metal, then we have large surface area, okay, for the reaction, and in such a condition the reaction completes successfully. So now we will study a reaction of silicon with water, okay, reaction of silicon with steam. Silicon is stable because there is covalent bond between silicon and silicon, so therefore if we put down silicon in water, nothing will be happen, okay. If we convert silicon into powdered form, silicon metal into powdered form, and we heat it with steam, then the product will be white solid of silicon dioxide, and hydrogen gas will be formed along with silicon dioxide, okay. Silicon dioxide is also called silica. So the first point you can see here that silicon will react with steam at red heat to produce silicon dioxide and hydrogen gas, okay. Silicon, the next point is this, that silicon is in the form of powdered, as I told you. Again you guys can see here that silicon oxidation state is 0, okay, and silicon dioxide state is +4. In silicon dioxide, silicon oxidation state is +4. It means silicon ionized 4 times. So the greater energy is required as compared to aluminium, magnesium and sodium for silicon to lose 4 electrons from its valence shell. So it means that the ionization energy of silicon is very high. Now we will study reaction of chlorine with water. So phosphorus and sulfur do not react with water, but chlorine can react with water. When we pass green color chlorine through water, consequently a reversible reaction is established between water and chlorine, and the final product will be hypochlorous acid, okay, and hydrochloric acid. As you guys can see here that when chlorine react with water, a reversible reaction is established between water and chlorine, and hydrochloric acid as well as hypochlorous acid is formed, okay. So you guys can see here that on first point is this, that chlorine dissolve in water to some extent to give a green color solution, okay. A reversible reaction take place to produce a mixture of hydrochloric acid and chloric 1 acid, hypochlorous acid. Chloric 1 acid is the IUPAC name of hypochlorous acid, okay. All this reaction happen in the absence of oxygen. So the next thing which I want to share with you guys, that reaction of chlorine with water. In this reaction the hypochlorous acid is very weak, okay. It is a very weak acid as well as unstable, and in the presence of light this reaction become irreversible and hypochlorous acid decompose into HCl plus oxygen. So here you guys can see that in the presence of light the hypochlorous acid decomposes into hydrochloric acid plus oxygen. So the whole reaction you guys can see here that 1 mole of chlorine will react with 1 mole of water, so 2 mole of hydrochloric acid plus oxygen is formed. Overall reaction in the presence of lead you guys can see here. So this was all about of reaction of period 3 elements with water. So see you in the next video. Wish you best of luck. Goodbye.